Hello everybody and welcome to the first of my demonstrations. This is just a brief overview of RATs or remote access Trojans. I'm going to be actually doing physical demonstrations of the top two. That's ProRat and the Beast. Those two, as you can see, are designed to attack a single host. The one on the bottom right here, Dark Comet, is actually probably closer to a botnet. As you can see, it's designed to handle and maintain multiple victims. It'll let you know what kind of operating system they're on. It will give you their admin rights, whether or not they're running a camera, what country they're in, and whether or not they're online. The reason why I'm not going to be doing a demonstration of Dark Comet or anything else like it right now is because those kinds of Trojans require a lot more infrastructure, and I didn't set that up for this. That's going to require some use of an outside website, sometimes some DNS routing, because part of that involves hiding yourself, because you're actually going to be sitting outside getting traffic routed through you, and you need that actually in effect when you're working with multiple victims the way you are. The top two were designed in around the turn of our century, around 1999-2000. They were around from the Windows 95, 98, and through Windows XP. The developers for both of them actually did full patches and maintained them through Windows XP. And I've seen several demonstrations where they're even used through Windows 7. Granted, a lot of the functionality is not going to work in these two, and a lot of the what these things do is more mischievous. You're going to have CD trays opening and closing, or you're going to be able to lock up the desktop picture. You're going to be able to hide files, hide other services, but they also have more powerful destructive features, like you can also go through their file system, you can do FTP, you can go through and change the registry, you can also, the biggest thing is the webcam desktop captures. I have a demonstration later on for both of those, and those still may actually work in later versions of Windows. And about Dark Comet, that actually the latest news I read about that was in actually in Syria. I had read that the Syrian government was actually using Dark Comet to keep track on some of its people. It is one of the preferred larger scale remote access Trojans that's in use. You'll see the other two in demonstrations as well as out in the wild. The biggest thing you'll see is they will actually do variations of these. They'll actually take the source code, they will customize them, they'll change them, but the basic code structure is the same. So if you go to a place like VirusTotal, or you run a virus scan, you'll eventually run into variants of the Beast as well as ProRat. So I am going to go with this, and I'm going to do a demonstration of the Beast as well as ProRat. Enjoy. A Trojan consists of a client and a server portion. What you see in front of you is the client portion, which goes on the attacker's computer. What I'm going to demonstrate here is how you create the server portion, which is what infects the victim's computer. As you can see, I have to enter the IP address, which is going to go here. This is the address that when you infect the victim's machine, everything is going to come back to this IP address. So as you can see, we still have the right IP address in here. General settings. I'm going to leave these with most of the general settings. I'll just explain a few of them. As you can see, a lot of this was created in the time when XP was popular. It was maintained a little bit past that point. And some of these features will still work, but a lot of them probably will not. Some of the more mischievous, shall we say, pieces to this won't work, but this thing will still take down firewalls. This thing will open up ports. This will deactivate antivirus. So I'm going to change a few more settings, and I'll go ahead and create the server. Let's see, I'll leave those. Server extensions. So the final product is going to be an executable file. And we're going to bind this with a file. What that means is it's going to be attached to some other file, and that other file is going to serve as the distraction. So when you open that other file, you'll be looking at what that other file is doing, while in the background the server is being installed on the computer. Okay, so it's bound with a file, and we've given it the settings. You can disregard that. And now it's creating the server. And this is our server. We shall now put this on our practice victim computer, and we will infect it. Okay, I've copied over the server we created using the rat, and now I'm going to infect the victim machine. You see, the picture, or even something like an executable, a game, or some other installed program will serve as a distraction. While you're looking at this picture, the server portion of the Trojan is being installed on the computer. Okay, I'm back on the attacker machine, and I am now connected with the server. I'm going to demonstrate a few of the things that ProRat can do once it's connected. Okay, this is my second rat. It's called Beast. I'm going to build another server, and I'm going to place it on the victim computer, and then we're going to see what kind of functionality the Beast has. So let's build our server. I'm going to leave most of the other settings at their defaults. I'm going to bind it with this icon. Okay, we're going to transfer it to the desktop while we move it over to continue. Okay. Disappeared because the option of melting on execution was clicked, which just basically means it executes, installs, and then disappears. NRC at 07. And we have a connection. And then we'll see how many of these things are actually working. First, we'll start off with the webcam. So you can see you can take snapshots in succession with Beast and have it saved to a local file. We can also peruse our victim's computer for files. We can also check out the running processes. We can also do a host of other things, but right now probably the most powerful thing that we'd be concerned about would be the webcam, because obviously it's disturbing when someone can get into your files, but it's even more disturbing when someone can video you or take lots of screenshots of you, because many people will leave their computers on and won't bother to check later, and who knows, someone could be watching. Hello, this section is a brief tutorial on rootkits, specifically the foo rootkit. Foo is a kernel level rootkit, and its main strength is that it hides processes. As you know, many times when a hacker compromises a system, he leaves behind a lot of extra things going on. Perhaps he's installed some extra programs to assist him in what he's doing, and like the list you see in front of you, it might leave some extra things that he doesn't want to be found out later by tools. So what foo does is it will hide processes by their process number. And as you can see right here, I executed foo, and it gave me a process list right here of all the numbers. And if you look, most of the executables, starting with SVC host, are all from my Trojan exercises. Whenever I created a server to test out with my Trojans, these are still running. So I'm just going to show you an example of how this works by hiding some of these processes. So if you not install, you don't install it. It's basically just an executable shell. If you put it in, like on your C drive, and you navigate to it from the DOS prompt, and you just run the executable with the -ph, that's process hide. You just pick out the process number that you want hidden. And for this case, I'll start with process number 964. So now I will do a process list. So let me get a dash. Well, You have to give it the number of processes you want displayed. Okay, and you'll notice that there is no more 964. I'll do another one. Process hide, and we'll 1108. Greetings everyone, and welcome back to the second video in my series. When an attacker targets a particular network, if he or she doesn't want to get caught, they have to take measures to be sure they stay hidden. The most popular way to do this is through the use of proxy chains. Proxy chains, as the name implies, are groups of proxy servers daisy-chained together. Proxy servers were originally used by large enterprise-sized organizations to serve as intermediaries between networks of workstations and the Internet. As time passed and networking technology changed, proxy servers were used privately for security and anonymity. If an individual could make use of chaining together proxy servers, he could bounce his traffic all over the globe if he so wished. The downside to using proxy chains is that it will very likely slow down all of your network transactions while you're working inside of the chain. The great advantage to using the proxy chain is that no one's going to be able to effectively trace you from your point of origin. If you're, say, in the United States and your proxy chain lead goes through Guam, China, Australia, or some other place in Europe, then no one can really effectively trace you. What I'm going to demonstrate here is I'm going to open up a password cracking tool inside of a proxy chain. Linux Backtrack comes with its own variety. It's simply called Proxy Chains. It's run from the command line. I have a configuration file for it open. If you scroll all the way to the bottom, like as you see here, this is where you place your list. You can go through and place all of your favorite SOCs and proxy servers, and it'll just cycle through these. But if you leave it at its default, it's going to take you through what is known as Tor. Tor, or the Tor project, or as it is also sometimes called, the Onion Router, was originally a technology that was developed by the U.S. Department of the Navy. That technology gradually morphed into a research and development project with thousands of volunteers, and its aim now is more purely towards personal privacy on the Internet. I'm going to leave this at its default, and I'm going to open up Xhydra, which is the password cracking tool, and I'm going to do a password cracking attack of one of my other virtual machines. Now that I've invoked proxy chains along with this tool, anything I do within this tool is going to be run through the proxy chain first. And now I'm going to put in the IP address of my target. And just for a moment, I'm going to take a look at an Nmap scan, which I ran on the virtual machine, which we're going to be using as a target. As you can see, there's a lot of information that we found during the scan, and that is primarily because I used this same virtual machine for our prior exercise, which had remote access Trojans on it. More specifically, you can see at the bottom here, Beast Trojan shows up, and there's a lot of other open ports. The Windows firewall is still on, and all these ports were still open just as a result of putting these Trojans on there. But also I'm running Bitfi's SSH server on this particular machine, and that runs on port 22. I added a very basic admin password, which is what we're going to show do a dictionary attack against. So this is the IP address of our victim in this case. The port number is going to be 22, which is the default for SSH services. Our protocol, of course, is SSH. We want it to be verbose, and we want it to show all the attempts. And for passwords, in this case, we're going to go with admin. If you so desired, in some cases, you could actually create your own text file, dictionary file of usernames. You know, add admin, administrator, or if you happen to actually find out what a person's username was, you could just add that here. But we are going to add our own password list, which is a text file. Linux Backtrack comes with a couple of default text files. In this case, we're going to use one that is located at, let's see, pentest, passwords, word lists. As you can see, this dictionary file is 133 megabytes, and this is just a text file. So you can imagine how large it is. If you're going to add additional things to this, it would probably be quite time consuming. But this is the file we're going to choose, and we're going to double check to make sure that everything is filled out. So SSH, target list, admin, and we are going to start our attack. When you run this, as you can see, it's going to most likely take a while because it's going to be running everything that you put in here through the proxy chain, and it's going to take some time. But you can see this is local, and it's already starting to run all of the start running the list, the words in the list, through the attempts. I'm not going to let this run all the way to completion unless it does happen while I'm finishing up here, but this is just to give you a brief example of how someone can call up a tool while hidden within a proxy chain. The next demonstration I'm going to do is using the Social Engineer's Toolkit, and we're going to clone a web page, and we're going to use Burp Suite to capture some of the traffic. Hello everyone, and welcome to the third and final video in this series. Meet the Social Engineer Toolkit. It was developed by Dave Kennedy. It uses the Metasploit framework. It was written in Python. It's menu-driven, and it makes use of exploitation methods such as cloned websites, injected Java applets, infected media, manipulated email, spoofed messaging, and even wireless attacks. The final result of an attack is usually either stolen usernames and passwords or an interpreter session on a victim machine. The attack that I'm going to be demonstrating today is called the Credential Harvester. This attack is accomplished by a cloned website. The attacker is going to be hosting that cloned website on an Apache web server. An altered login.php script is added to the cloned page, and it collects the username and password and passes it along in clear text. To find out how exactly the Social Engineer Toolkit exploits the login script would require some reverse engineering, which we're not going to do here. What we are going to be doing is using the Burp Suite proxy to capture and examine what takes place during the attack. For the attacker machine, I'll be using Kali Linux, and for the victim machine, I'll be using Linux Backtrack 5 Release 3. What I'm going to do first is demonstrate the Credential Harvester attack in real time. Then we'll examine the captured get and post comments in Burp Suite proxy. Let's begin the attack. First, we start off by selecting number 1, Social Engineering Attacks. Then number 2, Website Attack Vectors. And number 3, the credential harvester method. And we'll be using the site cloner. And we have to add a postback IP address. And for the site we're going to be cloning, okay, set is ready and it's listening on port 80, so now we'll go to our victim machine and we're going to bring up a browser. Just a brief word about the URL here. If this was actually being deployed into the wild, we would actually be using some other kind of redirect attack, such as DNS cache poisoning, maybe along with some port forwarding. But since we're all on the same subnet, all we have to do is just type in the URL of the attacking machine. And there it's Facebook is even remembered. So the last time I used this, the username and password has been entered. I'll click Login. It'll take a moment to process it. So I found ordinarily whenever I've used a number of different website cloners and rippers, if you provide it with a username and password, it will clone everything on the inside of the firewall. If you are using it in this fashion, it's going to clone everything outside of the firewall, specifically just the login screen, which is why when it finished processing, it just took us right back to the login screen. So now that it's finished, we will go back to our attacker machine. And you can see right here, let me better, we have a username and password which was captured. Now let's go examine the results in Burp Suite. Burp Suite is a Java application that's used to crack or test vulnerabilities in web applications. It's maintained by a company called Portswigger. Burp uses a number of different tools, including a spider, a scanner, and an automated attack tool called Intruder. We're going to be using a proxy tool. The intercept button in Burp has been turned off so that all the web transactions will pass through the application and then on to their final destination at the web server. If the intercept button had been left on, we could trap each transaction before it goes to the web server. This would allow us to make changes to the get and post commands before they go to the server. We'll go through the transactions that were generated during the harvesting attack. This will include the raw HTML as well as the parameters. All right, we'll go to the history. As you can see, start with the raw HTML. This is the first of the get commands, and this was when we typed in the URL to get us to the phony page. These, let's see, here is another one. And here was the actual login attempt. This is the most interesting one to look at because, as you can see, a cookie was generated, but this is the first right after we logged in. Now the username and password appear, and they're in plain text. Now we'll take a look at the parameters. Again, we see a reference to the username and the password, and all sorts of references to the body and other cookies. After examining the get and post commands that were generated during the attack, we don't know for sure exactly how the social engineer toolkit acquired the username and password, but it does give you an idea of where to look further. If you wanted to find out in more detail as to how the harvester works, you could turn the intercept button on and change some of the parameters and send them to the web server. This testing and reverse engineering might help you arrive at a solution.